But yeah, the best part that we saw, besides the fact they were able to rescue that growth using the same amount of feed, just having glycine supplemented, other than that exact same amount of feed, they were able to produce a better carcass quality too. So rather than, just growing them, getting them better, we wanted to make sure we also had a higher quality product at the end for consumers.
Swine.
Hello, and welcome to our latest edition of Swine podcast. I'm Jerry Purvis, your host. Today we have a very distinguished guest, Dr. Erin Posey. Dr. Posey is a UGR swine researcher currently, and has done a lot of work in amino acids and intrauterine growth restriction. Dr. Posey, welcome to our podcast today.
I'm happy to be here. Thank you for inviting me.
Very good. And so let's just tell us a little something about your career and how you got to where you are today.
Yeah, so I actually started in, I think like a lot of probably animal scientists, thinking I wanted to be a veterinarian. So I started in that field, grew up with the two veterinarian parents, and then kind of got to middle of undergrad and realized I did not want to be a veterinarian. I was obsessed with nutrition after taking one class in animal nutrition, and my parents both asked me what was wrong with me because they could never ever picture being obsessed with nutrition. But that kind of started me on the road towards grad school and doing research, and I got linked up with the animal science department because previously I was with the vet school in A&M in their undergrad program. And that's it was kind of a roundabout way, but I ended up with one professor in meat science and kind of started to work on protein metabolism that way and lipids and fats. And then, as happens a lot in academia, some funding fell through. And so I had to find a new advisor, and that's when Dr. Goya Wu asked me if I was still interested in being in his lab. And anyone who knows him knows he is the amino acids guy. That is his entire thing. He has this insane memory base for all things amino acids based and pathways. And so that's what kind of steered the rest of my grad school career, was ending up in amino acids nutrition, ended up working with swine, which I never thought I would. I thought I was going to be a horse nutritionist through and through. Ended up doing pig nutrition and loving it, loving everything about swine, getting more involved with it, and I ended up doing my entire PhD on intrauterine growth restricted, or IUGR, piglets, which then kind of led me to my postdoc. Took a human bend on that, looking at preterm piglets as a model for human infants, and still doing amino acid supplementation to help those piglets grow and hopefully help preterm infant humans in the future grow. And then I ended up working with the USDA and doing something completely different, but the swine industry still has my heart, and I was lucky enough to get sent to the American Association of Swine Veterinarians meeting back in Nashville a couple weeks ago, and really reminded me how much I love swine, even though I haven't gotten to do a lot with it in the last 6 months or so. But that's why I was so excited to get asked to be on this podcast. It reminded me, kind of brings me back around to swine.
Very good. It seems a lot of nutritionists, we end up going through that, that vet process, veterinary, and then we end up in swine nutrition. But I've got a lot of connections there with swine nutrition and amino acids, and understanding how we formulate those diets. And you're working on a really interesting topic of intrauterine growth restriction. And so I think that has a lot of potential pertinent, as we see in the industry, a lot of those small pigs. So maybe for our viewers that maybe don't quite understand, maybe tell us a little bit about what that is. What is that growth restriction, and how does that happen?
Yeah, so intrauterine growth restriction is kind of, to use the colloquialisms, is like the runts of the litter. They're the ones that are born small, and they just never seem to, do quite right in the growth period. They don't seem to grow as fast. They seem to have trouble with their feed efficiency, even if they're eating as much as, a normal birth weight pig would. They're just not growing as much. And it also leads to early death in these piglets. They don't tend to make it sometimes even to weaning. And if they do make it to weaning, they don't make it to production weight. And that comes from a couple different reasons, but one of which is we've bred sows selectively for so long for larger litter sizes and bigger litter numbers. And the sow's uterus can only get so big; it can't keep up. So we're breeding for, you know, high parity, more piglets, but some of those, drawback of that is smaller piglets. So it can be that sometimes it can be poor maternal nutrition. Sometimes, we talk about amino acids, what's included, what's not. So it's kind of a balance between those two. If we're growing these pigs so big, maybe there's a maternal nutrition component too, but a lot of it is just sheer size of the uterus. So not able to grow as big in the uterus, and then they come out small.
There's a better way to finish your pigs, and it's called Digesterone Finish. Digesterone Finish provides higher feed acceptance, leading to improved digestibility, so you get a more efficient finish. Made with all natural ingredients, Digesterone Finish is a three-way win for producers through better animal well-being, enhanced economic performance, and improved sustainability. Digesterone Finish can help you get more pounds in less time, so why wait for your finish? Learn more at dsm.com/finish.
Yeah, we've seen that on our end. You see those as you said. The genetics have selected for larger litter sizes, and with those larger litter sizes, each pig is a little smaller on average. So, kind of differentiate that. Is that part of the crowding, or is that the fact? We see that in late parity sows as well, where they have a lot of small pigs. Is that kind of maybe two different things,
Yeah,
issues there?
so like if you're just looking at the litter and you're saying, okay, well, these ones are small, those ones may or may not be IUGR. They might just be born small and they'll have no problem catching up at some point because they don't have the genetic issues that the IUGR pigs do. Those IUGR pigs have a true genetic issue where their small intestine isn't working as well. They're not able to absorb as much. That's why, like I said, they can eat as much as a normal pig, but they're just not going to grow. And so reduced feed efficiency, and they just can't keep up. So if you have, your older sows that are having on the whole a smaller birth weight, it's probably not going to be IUGR so much because that IUGR affects 15 to 20% of a litter. It's very rarely, or if ever, going to be an entire litter. Um, so it's also kind of looking at the average litter weight. So if all of them are under a kilo, I mean, then it may not be IUGR. They're just going to be small. So kind of goes to that.
So, as you look at defining what those pigs are, what are some characteristics of those pigs that you see and you're able to designate that's a restriction of space?
Mm-hmm. So the way we did it with a lot of our studies was, like I said, doing that kind of average litter weight and then cutting off at the 1 to 1.1 kilo. But it's something you can see pretty early on. It's like a failure to thrive. They're not keeping up as quickly with their other litter mates, not growing as rapidly. In just in those, even the first couple weeks after weaning, if they survive to weaning, and that's something you can see with that. And then just general GI issues because their small intestine's not able to work as well. So you see more GI problems there, and just kind of that general failure to thrive. Um, there is a test that you can use for it, looking at different ratios in the snout to face length, but we didn't use those for my study, so I'm not as familiar with them. But it's good to see people developing tools like that.
So, what do you think is the mechanism? These pigs are crowded. That's genetically predisposing these pigs to, as you say, a growth, issue, and they don't thrive, and they don't grow as fast as their average birth weight siblings. What is really happening there?
Yeah, I think that's a really interesting kind of area to look into. Um, I know you said like, we talked about this, just the sheer space issue, so they're not getting maybe as much maternal support as far as blood flow. Part of that could also be, we're not getting as much transfer of maternal immunity into those pigs because that blood flow is so much lower. Um, and then, maybe kind of right at the beginning, if they're the smaller ones, maybe they're not getting as much um, early on, like colostrum and things like that they need. So there's a bunch of different things that could potentially be causing that to, lead to like some genetic issues, like within the different immunomechanisms. Since their small intestines are a lot smaller on average, they're not functioning as well. The small intestine's a huge immune organ for these pigs, so it could be somewhere in there, something not quite getting turned on during that gestation period.
So maybe multiple factors that are at play here, not
Yeah,
necessarily one silver bullet.
definitely. And when we look at it and we see that, these piglets have a reduced capacity to even synthesize glycine. They have lower glycine in their tissues, lower glycine in their plasma. So there's something happening there where biochemically they're not at the stage they need to be at to function fully. So there's something definitely within that.
You go back years ago when sows, were having, 10, 12 pigs born, you didn't have to see that wide variation. But but most of our buildings are, 20, 30, even 40 years old. So we actually now as they've genetically selected for longer sows, we run out of crate space. We
Yeah,
got these old crates. So it's
yeah,
unless they're a gilt, once they get one or two parities, they don't fit in the crates.
yeah.
So it's
It's causing issues on all over the place.
yeah,
Yeah, no, definitely. Because I mean, more pigs out as long as if you think about kind of the ratios there, they're like, well, if I have to call a couple, like one or two early on, if I'm getting 20 piglets or 19 piglets or however many I can breed, it's kind of like they take the chance.
right. And so as you were looking at, you mentioned glycine, but you saw deficiencies in these pigs. Is that other amino acids you had deficiencies, or is that what made you?
Yeah, we've seen a bunch in our work, or in the Dr. Wu's labs work. We've seen a lot of different amino acids that are not produced as well. These IUGR pigs are not produced in abundance. Glycine is just the one that we kind of picked up for this study, but we've looked at arginine and different amino acids in that family, other ones that are stimulate muscle growth and things like that. So they tend to be on the lower end of all amino acids. And glycine is one of those, it's one of the simplest amino acids, so it can be endogenously synthesized. It can be kind of shunted to where it needs to go to become other amino acids. So if some of those are going to be on the lower end, then overall you're going to have a decreased production for those endogenous amino acids.
Very good. So just not dive. We're going to dive into your paper a little bit, but I was just curious. So you're saying, I think I'm saying these pigs are not going to grow as fast. Is there something you can do environmentally to offset that, like give them more space? We know space is real impactful to a pig's growth rate. Is there something we give them more space, more nutrition? Are there ways that we can offset this disadvantage with these pigs?
Yeah, I mean, as far as space, our piglets had a lot of space. We only had like 2 to 3 in a pen, so I mean, we gave them as much space as they could want and have, and it didn't, our controls still didn't, magically start growing bigger. And nutritionally, I mean, their feed intake is exactly the same as those normal birth weights, and they're just not growing. So I think if you continue to, give them more protein, yeah, you might see, an improvement, but that's, potentially just because they're getting other amino acids that they're deficient in if you're increasing that protein source to begin with. So I think it comes down to like a targeted therapeutic of some kind. And especially, I mean, if you're just going to throw more nutrition at them, your producers are going to look at that and go, well, that's 2 pigs that I'm feeding twice as much to, and that's not worth it. So that targeted therapy that's affordable is really, I think, not going to be a silver bullet, but it's definitely something that can help.
Very good. So let's dive into your paper a little bit. Very interesting paper. Like I said, we all fight these small pigs, and it seems litter size just keeps keeps growing and growing. Talk a little bit about your paper and your study and how you set that up and the
Yeah.
result.
So our study was looking at, we talked so much about IUGR. So, we wanted to see if there was a targeted therapy that we could use. And because amino acids are, was our lab's thing, we wanted to look at glycine in this instance. And that was due to some previous work that we had done looking at IUGR pigs, and we saw that they had reduced glycine concentration in their plasma and thought that was interesting. And then did some in vivo studies with some of those tissues and saw that the tissues had a reduced capacity to synthesize glycine. So that was interesting because it wasn't something that was expected. This was all kind of before I started in the lab. So by the time I got there, we wanted to do a full blown study, not just taking the tissues, doing in vitro. We wanted to see what happens if we actually feed this to an animal. Will that make a difference, or are those biochemical pathways just so trashed genetically that there's no rescuing it? And, we want to do this because, like we said, IGR is affecting 15 to 20% of just all pigs born globally in the swine industry. And, most of them die before weaning. So that's 76% of them. But if they do make it to market weight, or if they make it past weaning, they probably won't make it to market weight because they don't grow as fast. So they're culled pretty early. So it's a huge loss for the swine industry. And so we wanted to see, is there something we can feed that'll help these piglets grow so that way producers aren't wasting the time breeding, wasting the cost of the pig in instances where maybe they've already vaccinated, they've already done all these things, all this time and money invested just kind of to be culled, or if they do end up and just kind of sink their losses, grow them out to market weight, and then they get a lower quality carcass. So it's not ideal. So we're like, what can we feed? Can we feed this glycine? Will it work? And so we got piglets from a bunch of multiple litters, and our cutoff point was 1.1 kilogram at birth. So that way we knew that was our kind of cutoff point. And, we talked about how you can define IUGR and things like that. So this is not, the only way to define it. It was just kind of how we decided to do it based on, what a producer may see when they're out. And, it's just a quick, fast way that you can just weigh them and split them. And hopefully if you, got one in there that was just small, not true IUGR, that this glycine treatment wouldn't, negatively impact them. So that was the other thing we wanted to look at. If you just did this kind of quick and dirty sorting, would it still be okay? And so we took these piglets, sorted them into a 2x2, which means, we had two types of piglets. So we had a normal birth weight and an IUGR, so the growth restriction ones. And the normal birth weight was then split. One was a control and one was glycine. Same thing with IUGR. One was control, one was glycine. And then we fed them from day 21 all the way out to day 188. So that was about where they reached their carcass maturity weight, or what we would expect for the normal birth weight pigs. So about 250 pounds, 120 kilo in there. So we weighed them every other week once we got kind of out past weaning a little bit more, and weighed their bunks to see, how much are they eating on average in this pen. And then at the end of that, we worked with our meat science colleagues and did a full HACCP slaughter protocol so we could do all of our carcass quality measurements. And then when we got back to the lab, we did plasma analysis, muscle amino acid analysis, all sorts of things to see, the different amino acid concentrations and see what was happening in these tissues. So that was kind of, it was a really simplistic study and kind of concept, definitely not in work. Me and my lab mate were the two holding it down for quite a long time, feeding pigs twice a day and doing all of that fun grad school stuff. But yeah, it was a really interesting project, and it was actually my very first pig feeding project too. So no pressure there, since it was my dissertation work as well.
Yeah, I tell you, it's a lot of. We're running a trial like that. It's a lot of work. People don't realize the work, the daily, the data, and then making sure that data is taken accurately. So when you got to the end, you had your control pigs and you had your growth IUGR pigs. What did those were those pigs able to finish and grow at the same rate as your normal birth weight pigs with the glycine supplementation?
Yeah, the ones that were glycine supplemented caught up to their normal birth weight siblings. They, we looked at statistically, they were the same. They might have been a couple pounds lighter, but statistically, I mean, that's not going to make a huge difference in your overall carcass. Um, but yeah, the best part that we saw, besides the fact they were able to rescue that growth using the same amount of feed, just having glycine supplemented, other than that exact same amount of feed, they were able to produce a better carcass quality too. So rather than, just growing them, getting them better, we wanted to make sure we also had a higher quality product at the end for consumers.
And that's an interesting point. So these IUGR pigs not only grow slower, but their carcass is a little different. Maybe tell us a little bit about that
Yeah.
distinction.
So it's something that we kind of see in, interestingly, with my postdoc work, we had our preterm piglets, which are not quite the same as IUGR, but a lot of those same problems. They don't grow as well. And we see it in humans that if someone's born preterm, they're more predisposed towards obesity and different problems with fat and metabolic disorders. So when you have a pig that was born IUGR, we also end up having a fattier carcass. And so it would kind of, lead you to think maybe there's a metabolic disorder happening there, that it's just the back fat thickness is so much higher. So overall the quality is lower. Your total, loin eye area is lower. Just things, all of the different quality markers that we look at are not not great for an IUGR pig that made it all the way to market weight, or at least to where they called.
So that glycine was able to supplement glycine, was that able to fix that carcass difference? So their
Yeah,
carcass was.
we saw a higher quality carcass overall. Especially, like I said, we kept seeing the back fat thickness was that biggest thing that we saw change. It decreased by 18% in a supplemented IUGR pig versus a non-supplemented IUGR pig. And the muscle, like color values, were a lot better with the glycine supplementation, which was kind of interesting to me. Just because, I mean, the glycine with the with the back fat thickness, I thought, okay, like that kind of makes sense. We're working with the metabolic issues that are happening there. But the color change really made me start thinking like maybe it's an antioxidant situation. We've got glycine's a precursor for glutathione and things like that. So it was really interesting to see that kind of come out and say, okay, so glycine is obviously impacting all these different pathways. I mean, it's got its hands in everything, biochemically speaking. So it's interesting.
So you made a good point there. Is supporting the pigs in inherent antioxidant capabilities. Did you see a improvement in mortality? Interesting with supplementing and maybe taking care of that deficiency.
Yeah, they the ones that were supplemented overall, they had that, we talked about that failure to thrive. They overcame that and they showed a much better overall. I mean, personally, I thought it was more of like a quality of their existence sort of thing. I mean, they were running, they were doing normal pig things versus kind of the non-supplemented ones were just kind of a little slower, a little like not quite as rambunctious, not quite as active. So I think there is something there for the mortality. I don't remember the exact numbers. We did lose a couple of the non-supplemented ones during my portion of the project. I know they ran more versions after I graduated, um, but some of them. But in all fairness, we lost a couple from the other groups due to injury or things like that, from just different causes that happen in animal studies. So I don't know that I can speak 100% to that, but it does make sense to me that we would see that a reduction there. But typically, if your IUGR pigs make it past weaning, they have a better chance of making it, since only 25% actually make it to weaning. And since our study started at weaning, we weren't expecting to see a whole lot of loss.
So very interesting that you take and you made a difference, in that growth and that return. Just why did you use glycine? I know you mentioned earlier that arginine, you kind of got the same response using arginine, and we'll go in down that road a little bit about essential and non-essential. Let you talk about that a little bit. But so why did you choose glycine just on a practical for producers looking at practicality? What made you choose?
One of the cool things about glycine is it's simple amino acid, so it's pretty easy to synthesize. Its entire side chain is a single hydrogen. So really easy to make synthetic, and that means it's a lot cheaper. It runs about $1 per kilogram of glycine. If you can get, feed quality, large batches. Obviously, if you walk into a sports supplement store and pick it off the shelf, it's not going to be that cheap because we're talking human quality. But for your animal quality, it's very inexpensive. And what's nice is you can just mix it directly into your ration. That's what we did. We had our growing finisher rations, and we'd measure out, if we're giving them X amount of feed, well, we need 1% of that to be glycine. We measure it out and we just mix it in right there in the bunk. Obviously, for larger scale production, you'd want to do this in your mixers, but for our purposes, it was super easy to supplement. There was nothing complicated about it, and the inexpensiveness was really helpful. It's also incredibly palatable for the pigs. Glycine is, the gly word comes from glycose, which is means sugar or sweet, which is where we get glucose also. So they love it. Pigs love sweet anything, so they eat it up. There's no resistance to intake. So that's always nice because we always worry, once a pig doesn't like something, they're never going to eat it again. So making sure they have something palatable that we didn't have to do anything extra to. So again, keeping that cost low because it's just right out of the bat. It tastes good. So that's what we wanted, was something practical for producers that it's not going to cost them an arm and a leg because they're already running a real tight margin. And when you're talking about rescuing, you're trying to talk them into rescuing 1 or 2 pigs, you really got to make it worth that margin. And so if you're saying, oh, it's only $5 a kilo, it's like, well, that's out because I got to supplement it at this level and I've got, 500 head. That's just not feasible for me. But then you say, oh, it's only $1 a kilo and you can mix it right in. And oh, by the way, you don't have to sort out your IGR pigs. You can feed it to your other pigs at the same time because some of those other amino acids we worry, about, like nitrogen content, sulfur content, things like that, if they don't necessarily need it. Whereas glycine, you don't have that concern. So it's all around a good option for a producer to use without having to rework their entire diet or their entire feeding regimen.
That's very good because it's all about cost, as you know. We can save a pig, but so that's interesting. You take that, and you didn't really see a benefit with your normal pigs. So we're targeting that 10 to 15% of your pigs born alive, those small pigs. And he made a good point. A lot of times these pigs, we get no value for them. They maybe get culled at weaning or at birth. They may get culled. But even worse is those pigs that do make it, and then they're growing very slow. So now they've consumed feed. You said vaccines, medication. You're trying to get those pigs to market, and nothing's going to work. And so you've invested a lot of money in those pigs to try to save them. So you take a pig's worth $30, $35. You can start doing the math. It's probably a pretty decent return on investment.
Yeah, I think when we calculated it back out in this was all pre-pandemic stuff, so numbers have changed well since then. But I think we said it was about $18 recouped per pig rescued. So that's on top of your carcass that you're gonna get per pound of pig. This was just indirect cost of feeding, indirect cost of like wasted space on that sow that you bred and things like that. So I mean it's not inconsiderable with a large pig population.
And like you said, it's just simple. We can do that at formulation. We can just formulate that in and how much did you said it was like 1%. So it's pretty high level.
It's a pretty high level for an inclusion. But that's the other reason why we were wanting to keep it on the cheaper side and wanting to pick an amino acid that's not really expensive to synthesize or really expensive to acquire, or it has to be modified a bunch of ways so the pigs will actually eat it, because a lot of those, like the ones you see in workout, stores like branched chain amino acids. That's all the rage for growing skeletal muscle. But man, they taste terrible if you
Yeah.
don't do something to them. We had to feed it to our preterm pigs in my postdoc and had a heck of a time getting them to eat it because it's so bitter. So I appreciated the glycine study a lot more after having to feed something so gross.
Yeah, it's they gotta eat to grow. That's for sure.
Hmm.
If they don't eat it, they're not gonna grow. It's kind of this is a good segue into our last point, but looking at essential and non-essential amino acids, and maybe for our viewers out there that are not nutritionists, kind of talk about what that is. What is the difference in essential and non-essential amino acids that we formulate in our diets?
Yeah. So I'll give like the official nutrition definition and then kind of like how we kind of interpret it in my area. So, an essential amino acid is something that the body does not synthesize. It's something that the body does not synthesize, and so it's something that has to be produced or provided in the diet. So that's an essential amino acid. It is essential that you eat it, essentially. So then, a non-essential amino acid is one that your body does have the biochemical machinery and the capability to synthesize. So it is non-essential that you don't have to eat them to get it. And so that's just kind of the cut and dry, how all, burgeoning nutritionists are taught non-essential, essential. And, just kind of like an example, we cannot synthesize in our bodies anything with sulfur. So any sulfur containing amino acids are going to be essential. You have to eat them. You can't synthesize sulfur. That's not something we can do. So that's just, but it's a sticking point, especially for my PhD advisor, Dr. Wu, because his kind of rationale just overall is that if your body can produce it and evolve to produce these amino acids, they are probably the most essential amino acids because they were so essential you developed a way to make them. So he's looking at it as from a health perspective, like this is essential to your health. And that he comes by that and as his grad student kind of the same way, a lot of the public, the popular press will hear, oh, non-essential amino acid, I don't need it. When really it's, I don't need it for health purposes. And it's like, well, actually, you probably really need it because your body will make it. Um, and so it's kind of this interesting dichotomy. And so one of the things that we kind of really push for is to say, dietary essential or dietary non-essential. So it's kind of putting that in front of it to preface it and say, this is only in your diet. It's not for your overall health. So that way popular press doesn't kind of run with things like they like to do and misconstrue stuff. So that's but glycine, about glycine is it's one of those things that's considered dietary non-essential. We can synthesize glycine, but then the question comes, okay, we can as humans and pigs can too, but can they synthesize enough? It's like, yes, I can in theory, I can synthesize this and I can synthesize all these different amino acids, and the pig can too, but enough to grow, especially if they're in that stressed IUGR state. And so that's kind of where that comes in of, what are we, how are we defining these things and looking at our overall swine nutrition? Do we really need to, just balance for one or the other? Something that I come across a lot just in my kind of personal nutrition life with equine is everything's based on lysine, and that's it. And they don't need anything
Yeah.
else. That's the only amino acid they need. And they've gotten a little better. I've started to see methionine and threonine included on those diet labels, but it's not required. Um, so it's those types of things that we really have to look at as kind of an industry, and how are we going to assess these things? And should we say this is a conditionally essential amino acid? If they're IUGR, if they're sick, if they're low birth weight, how do we how are we going to, kind of parse that out as we go forward?
Yeah, good points. So just to summarize, your essential amino acids, or dietary amino acids, really is what we're saying. They have to be provided in the diet. That pig. Let's just use pigs. Pigs you got to put that in the diet. For their requirement. And then these non-essentials, they do have the capacity to synthesize these amino acids. But to your point, there times maybe in stress or in season, heat stress, other stresses, environmental stresses, that pig impairs that pig from being able to produce enough of that non-essential, like glycine. So you think that's where some of our work's going to go is seeing maybe there's a requirement depending on your stress level, or a summer versus colder weather.
Yeah, I think that's something that a lot of research is kind of, I know at least with you brought up heat stress, I've seen a couple different talks at animal science meetings and things like that, people looking at supplementing amino acids either to sows during heat stress to reduce, growth restriction in their piglets, but also just to reduce overall heat stress on the animal. So I think it's something that the industry is kind of starting to look at least researchers are starting to kind of get more invested in this idea. I think amino acids are this kind of big, nebulous, and also complicated thing to people to look at. I know that's how I felt. I never wanted to study amino acids ever. And I wanted to stick with carbohydrates and fats because they all kind of, once you learned them, they all kind of did the same thing. And then amino acids, it's like you start to think you understand one and it affects so many other things. And it's not just skeletal muscle, it's, immunology, it's overall just health, it goes everywhere. And so they get really complicated. And I think it's something that kind of makes people, anxious about wanting to do a study with it is, well, I know it can do this, but what else is it going to affect? Am I going to cause more problems than it's worth? And it's a lot. But I think the people are starting to look at it more and more seriously, from a not just feeding the animal perspective, but from a supporting the overall health of the animal and treating those different, not treating with medicine, but treating with amino acid support those stressed animals. Yeah.
Yeah, yeah. It almost seems on the human side. Now there's more of a buzzword. Your protein, getting the right amount of protein, and how that impacts, like you said, your health. We can improve our health as maybe we don't consume as much protein as we probably should, but very interesting on the pig side. It's so we've taken a non-essential. That whole glycine is really interesting because take glutathione. Some of these antioxidants. We found 95% of our mortality is in that last trimester of sow mortality through lactation. So during a time when they've got the most oxidative stress. So that connection there, that glycine being kind of a precursor to glutathione, I think that's a good.
Yeah, that was a really interesting paper that my lab mate ended up putting out after I left. Mine was, I looked at the creatine side of things, and creatine obviously, big workout buzzword for muscle growth and stimulation, but also a really powerful antioxidant. So it kind of does double duty there. So the fact that my lab mate, then he kind of went the other way and did glutathione and also saw similar increases like I did with creatine. It was like, wow, so this glycine is really kind of pulling its weight here, in a lot of different ways, from an antioxidative, situation all the way up to just sheer growth. So it was really cool. I was very impressed with glycine and its little single side chain.
Yeah, it's an interesting topic. Where do you think now you're going to go? Now you've done this and you've got some good results here. What do you think your next step is?
Yeah, I think a lot of it is, so we just got some of these papers out recently. I think a lot of it is kind of getting the rest of those papers out to kind of flesh out the whole story for everybody, kind of showing the different ways we went, and enabling other researchers to kind of, springboard off of that, maybe some of these, Midwestern area schools that don't have to take a break from swine research in the summer like we do because it gets so hot down in Texas, able to kind of work through that. I don't think, we're not really looking to, patent any type of product. That's definitely not my professor's his kind of game. And it's be really hard to say I'm patenting glycine. I mean, I guess we could slap a fancy name on it and sell it
Yeah.
for whatever. But the whole point was wanting to make it accessible for producers and making it something that they don't need, this complicated nutrition background understanding to be able to implement. So I think our goal is really just to get the information out there for these producers so that way they can, make informed choices about how they want to move forward. And, I'm sure most of them have nutritionists that they use and they can always say, hey, like I heard about this and what do you think? And then that kind of spurs more conversation between like your industry nutritionist and your research nutritionist. And then we can move forward kind of in this, working together sort of way. And I think it's something that a lot of the academia research community can lose sight of, what is actually feasible for industry. It's something that I began to appreciate a lot more once I started to work with USDA and seeing the boots on the ground of these huge swine operations because I didn't come from a swine background, so my only swine exposure was research. And well, it's not that hard to supplement 6 pigs in this really complicated way, but then you're talking hundreds and hundreds of pigs and just fast turnover and different levels of of worker experience. Just you got to make things simple and fast and easy to understand. So it's I think it's really good if we can kind of have that conversation between an industry nutritionist and these academics and really find a cohesive way of doing things.
Yeah, as a producer, I can really appreciate this kind of work because I think it's very pertinent to, our bottom line. Now
Yeah.
we can make, I don't think we're not gonna go backwards and have less pigs. I don't think.
No, that I think that ship has sailed.
Yeah, and I don't think we're going to go back and there's a lot of systems are not just going to be able to put in bigger crates,
Hmm.
and so I think we're at a crossroads here, and I think this is a very good point that maybe we can mitigate some of these with diet, and so we can live with the things that we can't change, but we can maybe and we save pigs, that's going to be very financially impactful. So very good. I think it's good work, and I like this kind of work that you can take and go. You can see the real pertinent impact there to our bottom line. So
It's time for our famous 3. Why risk it? Your herd may have antigenic gaps that are not being covered by the products currently available. Custom-made vaccines provide a unique advantage in that they can be formulated to a herd's specific bacterial and viral needs. Choose the exact isolates, adjuvant, packaging, and size you need with Vaccinova for a vaccine formulated to your needs. Find out more by visiting us at vaccinova.us.com. That's VAXXINOVA.us.com.
well, we're about out of time, and so we got to ask you the 3 questions. First one is your favorite resource. What's your favorite swine resource, or it could be nonfiction or
Yeah. My favorite swine resource. I'm on a bunch of different committees for the American Society of Animal Science, so I get a lot of stuff kind of from them. I'm on their non-ruminant nutrition planning committee, so I kind of go to ASAS first. Honestly, a lot of stuff I get now is for swine nutrition. Is Dan Columbus, who I think y'all work with pretty frequently. I see his LinkedIn post all the time, so I get lots of fresh information from him
yep.
posting that.
Very good. Yeah, ASAS, that's a good resource, and you can find papers on a lot of different topics. So
Yeah, I'm trying to get him to kind of move more towards industry partners too. So funny that we talked
yeah,
about that a little bit. Was got to get the industry in.
that's right. So now thinking about your career, who would you say maybe was your most influential person on your career?
I definitely would have to say Dr. Goya Wu, my PhD advisor. He's demands perfection and he pushes you, but at the end of the day, I learned more than I thought I would ever learn, and he made me, despite my best efforts, he made me love amino acid nutrition and really got me to appreciate what all is there. So I don't think my career would have taken the trajectory it had if I hadn't some weird happenstance hadn't ended up in his class in grad school.
Very good. Yes, it's amazing how one person can spark an interest in a certain area and you take it off the rest of your career.
Yep, but he's got an infectious passion for amino acids.
Very good. Yeah. So lastly, what would you say in talking about swine research? What are the characteristics of a good researcher? You think that makes a person a good researcher?
I think the characteristics, one of the biggest ones that always comes to mind because it got me through grad school is the idea of persistence. You can be brilliant and you can be, well learned, but persistence is what's going to make it in the end. You have to keep pushing and keep trying new things and being willing to, and persist. With persistence comes the ability to take, criticism and being, that whole idea of firm in your goals but flexible in your methods. And so being able to take what you hear and don't necessarily give up on your ideas too fast, but be willing to take that feedback. So I think persistence is probably one of the top in my book, closely followed by the ability to step back from the trees and make sure you're still looking at the whole forest. And that one's also, near and dear to my heart because I got told that a lot in grad school. I started at the trees and worked my way out to the forest, and my advisors always had to tell me, you have to start here and work your way down. If you go the other way, you're going to miss the big picture before you even start. And so I think that's kind of, like goes to what we were saying with the academia and industry, partnerships. You have to see the whole swine production picture. You can't just look at this little nuance piece. You have to be able to see that. And so I think those are probably the two biggest ones, and they've carried me well through my whole career. And I like to think I'm a decent researcher. So I think persistence and the ability to see the whole picture and not get too focused in your trees right away. I mean, you can always go in there later, but
I agree 100%. Agree 100%. It's you're gonna fail a lot, and sometimes you're gonna you just keep pushing through, and maybe you got a study, it didn't come out the way you thought, but
yep.
You got to regroup sometimes, but you keep on going, and so that's very good point. And your point about the industry, it doesn't do if it's some work that doesn't really it's something that I can't act on that the industry can use, and it kind of gets lost in the shuffle. It makes it really important. Like this work here, I think is really pertinent. And and then the funding comes, as you get, as you say, if we can turn around and increase, the amount of pigs, the amount of pork that we produce, then that's going to help everybody. So consumers and producers, so it's good for everybody.
Definitely.
So, very good. Well, I appreciate you coming on our podcast today, and good luck in the future with your work. Thank you.